Okay, in this chapter, chapter 13, we're only going to be doing 4 lessons, like half the chapter. I'm going to take the most important things out of the chapter. The reason why we do chapter 13, number one, if you have not had geometry, it'll make geometry easier, at least a couple of chapters in geometry. If you've had geometry, it's a good review. And number 3, on standardized tests, college entrance exams like the SAT and the ACT, we'll have questions like this about triangles and trigonometry is what it's called. So those are a couple of the reasons why we study this. Right triangle trigonometry. Trigonometry is the study of relationships among angles and sides of a right triangle. You can think of tri is 3. Tricycle has 3 tires. A bicycle has 2 tires. Trigonometry is the study or the measurements of 3-sided objects. 3-sided objects are triangles, so this is why it's called trigonometry. We usually don't say trigonometry, we usually just say trig because it's easier and it's shorter. Trig. So, theta, angle theta, this letter right here, this is a Greek letter, and it's spelled theta, looks like the with a T-A, theta, and it's very common in higher level math to refer to angles with this Greek letter or other Greek letters. In geometry, you may just refer to this as angle A, but we'll be calling it angle theta. You could see either one, but theta is more common the higher that you go. And it's really important that you can identify the sides of a triangle relative to the angle that you're looking at. So across from the 90 degrees, this little box is 90 degrees. Across from the 90 degree is called the hypotenuse. Hypotenuse, which is spelled right here. Hypotenuse. It's the longest side of the triangle, across from 90, hypotenuse. Now, across from A is this side, and that's called the opposite side. Opposite side is OPP, opposite of the angle. And the last side, so we have 2 out of 3, the side that makes up the angle angle A, is made up of 2 sides. One's the hypotenuse, the other is called the adjacent side. The adjacent side, ADJ. Adjacent means next to. So you are adjacent to whoever you're sitting next to. You're right next to them. So the adjacent side is next to the angle, and it forms the angle. So it's really important you can tell the difference. If we were talking about angle B, then the hypotenuse stays the same, but the opposite is now at the bottom. So it switches. The adjacent is now over here. So it depends what angle you're looking at. It's important that you can identify those because you have these really popular trig ratios that you have a lot of context to use these. It's a relationship between an angle and the side lengths of a right triangle. These only work for right triangles. So a ratio, a fraction, between the opposite and the hypotenuse is called sine. It looks like S-I-N. It's abbreviated sin, but we don't say sin, we say sine. Sine theta is opposite, which is this side, over hypotenuse. That ratio can give you what this angle is. Cosine, C-O-S, is the abbreviation. Cosine theta is adjacent over hypotenuse. So it would be adjacent over hypotenuse is cosine of the angle. And then the last type is tangent, T-A-N, and that's opposite over adjacent. So opposite over adjacent is tangent. I'd like you to memorize these 3. One way that some people use to memorize them is a mnemonic device. And you say, so, ka, toa. So-ka toa. And that's a way to remember the relationships. What in the world does this mean? Well, if you look, sine starts with an S, and it's opposite over hypotenuse. S-O-H is so. C is cosine. Adjacent over hypotenuse is C-A-H, so ka. And then tangent is T-O-A. So that would be toa. T-O-A, so-ka toa. So you can remember this, or you could just memorize what the relationships are, but you need to remember the name and what sides it's related to. It's also important that you can pronounce this right. If you don't know how to pronounce it, it's not really helpful mnemonic. If you pronounce this as sa-ka-ta-a or something, it's not going to help. If you don't know how to spell it, it's not going to help. So you need to know how to say it and how to spell it. So-ka-toa. So-ka-toa. One last note. Sine, cosine, tangent always have an angle measure or a variable after it. So you will never see this unless you wrote it wrong. Sine equals 1 over 2. This is incorrect. It should be sine theta equals 1 over 2. Sine is an operation and it needs something to operate on. So you have sine of a number or sine of a variable. Something that you may or may not have learned in geometry are called reciprocal functions. The main thing I want you to know about these is the names, which one goes with which, and then the abbreviations. But other than that, we don't use them too frequently. So this is called cosecant, and you abbreviate it with CSC. You can't abbreviate it with CSO because that's cosine. So cosecant is the reciprocal of sine. So if you remember a reciprocal, if you have 2 over 3, the reciprocal is 3 over 2. So cosecant is the reciprocal of sine. So sine theta is opposite over hypotenuse. Cosecant theta is the reciprocal, hypotenuse over opposite. Secant is the reciprocal of cosine, and you abbreviate it with SEC. Secant theta equals hypotenuse over adjacent because cosine theta is adjacent over hypotenuse. And the reciprocal of that is secant. Cotangent is pretty easy to figure out. It's the reciprocal of tangent. COT is the abbreviation, COT. That's because tangent theta is O over A, and the reciprocal is adjacent over opposite. So again, I want you to know the names, how to abbreviate. Secant is SEC, and then it would be hypotenuse over adjacent. So I want you to know those things. We'll use all 6. Find the values of 6 trig functions, trig ratios for these. So if you need to, it's helpful. Identify where your angle is. We're talking about angle B. Opposite of angle B is 3. The hypotenuse is across from the 90 degree, so it's over here, is 5. And the adjacent side makes up the angle, which is 4. So then you can state sine theta, cosine theta, tangent theta. Sine theta is opposite over hypotenuse, which is 3 over 5. Cosine theta is adjacent over hypotenuse, which is 4 over 5. And tangent theta is opposite over adjacent, 3 over 4. And once you identify those, then you just take reciprocals of each one with reciprocal functions. So the reciprocal of sine is cosecant theta, and the reciprocal is 5/3. Cosine is secant theta, which is 5/4, and cotangent theta would be 4/3. So on the next problem, I'm going to give you a chance. Notice the angle is up top at angle G, is where theta is. If you need to identify which one's opposite, adjacent, and hypotenuse, and then I want you to state the 6 trig functions and what they equal. And I'll write the first 3 and see if you could do those. Okay, we use trig ratios to solve for missing sides. So on these, you're only going to pick from one of 3, sine, cosine, or tangent. So for this, notice where your angle is, 43 degrees. It's a right triangle. You're given the hypotenuse across from the 90. And you're looking for the opposite side of 43. So you need to pick sine, cosine, or tangent that has ratio of opposite and hypotenuse. So with the mnemonic, SOH would be the one that you would want to choose. So you have sine of 43 degrees equals opposite over hypotenuse. To solve this for x, you multiply both sides by 11. And you take your calculator out. On your calculator, you're going to type 11 sine 43, and be really careful that your calculator is in degree mode. Your calculator has two different modes. One's called degree mode, which is what we want. The other is called radian mode. Radian mode we'll talk about tomorrow. But if you go right here on mode, it should be highlighted on degree. If it's not, then you have to fix it. If it looks like this, and all these are, this one right here, radian, if that's bolded, you don't want that. You go over here, hit enter, and make sure it's bold on degree. Okay, so you can quit out of that. Second mode quits out of that. And now when you hit enter, the calculator understands you mean 43 degrees. So you hit enter and you should get the answer of 7.502. Whatever the units are. On the next one, you're given this angle. Notice the 90 degree is up here now. So across from 90 is the hypotenuse. And then you're looking for x. Is x the opposite, or is x the adjacent side? X is the adjacent side. So, with SOH, you want adjacent and hypotenuse, which would be cosine. So cosine of 30 degrees equals adjacent over hypotenuse, which would be 8. Cosine 30 equals x. Eight cosine 30 equals 6.928 units. Okay, the next part, these are important relationships. 45, 45, 90 degree triangle and 30, 60, 90 degree triangle. These occur often on college entrance exams like the SAT. So I want you to memorize these relationships, and we're going to use them a lot tomorrow in class. So 45, 45, 90, we'll put the angles here. The 90 is already given, is right here. And the side lengths are a 1, and a square root of 2. You could put x, x, and x square root 2. But this should make sense with the Pythagorean theorem. If these two sides are the same, you're going to get 2 equals h squared. H is the square root of 2. So 1 square root of 2. We'll use those numbers a lot tomorrow. And 30, 60, 90, we'll put 30 up top with the smaller angle, 60 at the bottom. Across from 30 is a 1. Across from 60 is square root 3. And then we can find the hypotenuse if we like to know what it is. So you have 1 squared plus square root of 3 squared equals h squared. 1 plus 3 equals h squared. H is 2. So the hypotenuse is 2. So what I want you to do is memorize these numbers and the angle that goes across from the numbers. And then memorize these numbers and the angle that goes across from the numbers. If you remember that 30, 60, 90 are in order, smallest to largest, 30, 60, 90. 1 is the smallest side, and it goes across from the 30. 2 is the longest side. It goes across from the biggest angle. And square root of 3 goes right in the middle. Square root of 3 is 1.7. So that's 60 is square root of 3. Okay, on the next one it says solve a triangle. To solve a triangle, ABC, that means solve for everything, every angle and every side you need to solve. So to solve a triangle, we draw the triangle first. Angle C is the right angle, so we'll put C right here. We'll put A right here and B over here. We're given that lowercase a is 12. So across from A, this side is 12. And lowercase b is the side across from angle B. And that's 5 down here. It doesn't really matter if you switch A and B, as long as you put the correct sides across from A and across from B. So you could put A at the top. But first, we could solve for the missing side here with Pythagorean theorem, which would be 25 plus 144 is 169 is c squared. So this side would be 13, the square root of 169. And then number 2, we'll solve for angle A. I like to pick the angles in alphabetical order. If I have a choice between A or B, I'll pick A, just because it's first in the alphabet. So with angle A, you can pick any of the 3 trig ratios, sine, cosine, or tangent. You're given everything. So I'll just use sine of A. And that would be opposite, which is 12, divided by the hypotenuse, which is 13. And then we get stuck. And the question is, how do you solve for an angle when sine is next to it? You're missing an angle. The way you do this, you have to get rid of sine. It's an operation. You have to undo sine. So you have to do the inverse of sine. So the inverse of sine is 12 over 13. I gave you directions right here how to do this on the calculator. It's going to look like this. You're going to have second button and then sine. And that will be the inverse of sine. And then 12 divided by 13. And the answer that you get is an angle. So the answer you get is 67.4 degrees. And then the last one, for angle B. Angle B, you could use another trig ratio. You could do sine of B equals 5 over 13. You could do cosine of B is 12 over 13. You could do one of those, or a much faster way would be to say A plus B is 90 degrees. So you could do angle B is 90 minus 67.4 to get 22.6 degrees. And now this triangle is solved. We know every side and we know every angle. Okay, I'd like you to try the next one. See if you can pick sine, cosine, or tangent, and then use your calculator to get the answer.